Alright guys, we're going to continue through the exercises from the notes that we began last class. And in exercise 2, we're talking about the height of a yo-yo. And it says that the height is modeled using this equation. So we're just going to keep this in mind. It looks like h represents height of the yo-yo in feet above the ground, and t is time in seconds since the yo-yo was first dropped. So notice we're using a cosine function. That's a pretty important indicator that your graph, and since it's a positive cosine, is going to look something like this. We're going to start at its peak, and then it's going to come down, and it's come back up, and it's going to cycle like that, because remember, cosine functions start at a maximum, and a sine function would start at its midline. So that's not what we're dealing with. Okay, so it's going to begin at its maximum, and it says to determine that maximum and the minimum height that the yo-yo reaches above the ground. So using this picture, I'm thinking to myself, this is the highest point that it reaches, max, and then there is a minimum point that it reaches as well. And I've got to find that point. This midline is going to be very useful to us, because remember that the distance between the midline and these points is the same. So where I find this midline in my equation is from D, and our D value is 2.25. So if I take that D value and I add to it or subtract from it the amplitude, then I should get my max and I should get my min. So if my midline is at 2.25 and I add my amplitude, now my amplitude is 1.75 because that's A. So plus 1.75, then I should end up with 4 feet. And if I subtract 1.75 instead, then I should end up with 0.5 feet. So it looks like my maximum value would be 4, and my minimum value would be 0.5, and those are in feet. So it's important just to understand that what these values mean. They have meaning within the context of these real-world applications, because this number, this amplitude, is telling us how high the function is going to rise above its middle, which is clearly 2.25. So in this case, that tells us what the highest point this yo-yo reaches and what the lowest point is that the yo-yo reaches. Part B says, how much time does it take for the yo-yo to return to the maximum height for the first time? So in our picture, what I've graphed here is starting at a maximum, it goes down, goes to its minimum, comes back up, and it's at its maximum. We have a name for that part of the function. If I go from here to here, that behavior represents one full cycle. So that's what they're wondering about. What is the distance or the time that it takes for that full cycle? And we have a vocabulary term that talks about the time it takes for a full cycle. That's period. And we can find period by just doing 2 pi divided by whatever b is. In this case, our b value is pi. So I'm just going to do 2 pi divided by pi, leaving me with 2. So how much time does it take for the yo-yo to return to the maximum height for the first time? 2 seconds. All right, so exercise 2 is just playing around with midlines, amplitudes, and what that means for max and mins, and then what period means within the context of these problems.